Alright, so that will be a brief introduction of database normalization. The goal of database normalization is to organize a database so that it compiles with those normal form and reduce the data redundancy and make it efficient. The first normal form basically tells to ensure that there's no repeating groups of data and ensures that there is a primary key. For example, when you first doing the database table and you want to record that every member in your group attend a meeting or not. So imagine you you will need to write down the yes for attend and then no for not attending. But you also have the other attributes like the member's name, state, address, etc. So imagine if you is a member attend the meeting consecutively twice, like a week, you will have identical exact same columns, no, same rows in your tables. That's not allowed by the first norm form. And the second norm form is each table should only contain the information that depend on the primary key. So that which means there must be no partial dependence of any their columns on the primary key. For the second norm form, I personally think is especially for a table which has two primary key. For example, like you have a table and its primary key is the student and the class. And also these two are primary key, but you also have like class, the materials that required for the class and the student grade. So the student grade is dependent on the student ID, but it's not dependent on the class, and the class material is dependent on the class, but it's not has nothing to do with the student. Uh, so that is an example which second norm form is violated. And a third norm form here that requires that it is in second norm form first, and all non-primary fields are dependent on the primary key. So none of the columns should have dependency with any other non-primary column. A simple example would be um, you have a table that has all the information of one of your member, including member ID, member name, member zip code, member address, state address, street address, etc. But the state and the street address is dependent on the zip code. So that is violation of a third norm form. You want to have a separate independent table to record every zip code as a primary key in that table, and followed by the state, street address, apartment room number. A BCNF is basically says primary key cannot have dependence. In a simple words, that is for dependency A to B, A cannot be a non-prime attribute if B is a prime attribute. So because 4NF, 5NF, and 6NF are only for knowledge, I will read them off. 4NF is it is in BCNF and it has no multi-value dependency. And 5NF is uh, it is in 4NF plus it cannot have a lossless decomposition into any number of smaller tables. 6NF means that every relation consists of a candidate key plus no more than one other attribute. So a table is in sixth norm form if and only if it satisfies no non-trivial join dependency at all, meaning that the fifth norm form is also satisfied. The sixth norm form was only defined when extending the relational model to take into account the temporal dimension. So why do we need to normalize the information? It's because normalization is a technique that which is used to avoid insert, update, and delete anomalies. Uh, by that, what I mean is if you not normalize your data when you're doing the insertion, update, and delete, there might be some issues. Um, yes, as they said, the normalization is not benefit for the static data. What are the drawbacks of performing normalization? First, first you're gonna have a lot of tables, obviously. So if you don't normalize the data, you will have a huge chunk of table. Just a huge table that contains maybe thousands of columns and huge attributes. But in order to satisfy those normalization, more and more table will be created in order to maintain that normalization rules. It can become very tedious, and the database just becomes harder to realize as well. And the database becomes extremely difficult to query against as the data model is optimized for applications. It's a computer program, as the sub tables increase, you just take more time to extract the information you want. So what are three anomalies? The first anomalies is insertion anomalies. Um, let's say the insertion first. Just as I mentioned, if the one table does not satisfy the second normalization form, it will have two primary keys. But imagine that two primary attributes be student and a class. And what if the student has not registered for the class yet, but the class has some new materials needs you to update them? Well, you're in a situation that you're missing a primary attribute while the table has to be updated. So basically, you're stuck, and yeah, that's bad. And the deletion anomaly is sorry, I went from bottom up. And the deletion anomaly is unintended loss of data due to deletion of other data. Ignore that example because it's I get it. So imagine you only want to delete the zip code, but it's end up like you delayed the whole. You know, I mean, the better example will be if there is a repetition of your data and you want to only delete one row, but it end up the same zip code is showed in multiple rows and accidentally delete them all, which you don't want to do. The insertion anomaly, the update anomaly is a data inconsistency that result from data redundancy and partial update. That's obvious. Like if some table is not follow the third norm form, and you want to update zip code, but the zip code is also dependent. Not the other way around. Your address, street address, apartment is also dependent on the zip code. You cannot only update the zip code. So If you only update zip code, they will be inconsistent. What are determinant whatever? The determinant in a database table is any attributes that you can use to determine the values assigned to other attributes in the same row. Well, the super key would be the minimum candidate key. Well, I think the candidate key it kind of means the same thing, that some combination of attributes can be used to determine the value assigned to other attributes. What are the functional dependency? So first is functionally dependency, and that means an attribute is fully functional dependent on the other attribute. It is a functional dependent on that attribute and not on any of its proper subset. Well, it sounds confusing. I read it again. So an attribute is fully functional dependent on another attribute if it is functionally dependent on that attribute and not on any of its proper subset. For example, if attribute Q is fully functional dependent on other attribute P, if it is functionally dependent on P and not on any of the proper subset of P. The second form of dependency is transitive. When an indirect relationship causes functional dependency, it is called a transitive dependency. If P is related to Q and Q is related to R is true, then P to R is transitive dependency. The last one is the partial dependency, which occurs when a non-primary attribute is functionally dependent on the part of candidate key. So for example, this is example database table that is not normalized. Well, you can see the first row, the full name is Jeanette Jones, and he lives in the, well, I'm sorry, she lives in the first straight plot number 4. But the issue is she rented 2 movies, but this table has both of the movie name in one row, which violates the first norm form. Like each row should have a single value. And also the same thing happened in the categories, that's action, and also same thing happened in the second row. They have 2 movies together for the robot field. So how can we make it right? The first norm form ensures that each table cell should only contain a single value, and each record should be unique, and also therefore we require both a full name and address to identify the record uniquely. That's a composite key. So we make sure that each record have, each row have a primary key. Well, here is the second norm form rules. Well, you see the last slide is their primary key is a composite key, which is combination of the full name and the physical address. But you know the physical address. But you know the physical address has nothing to do with the movie rented. The movie rented is only like related to the membership ID, right? So there is a partial dependence on this table. The thing that we can make it right is you create a separate table that only contains a member ID and will be rented. That way, uh, each primary key will only has like basically there's no partial dependency anymore. And the third norm form rules, well, you can see here why it violates the third norm form, because here solution is related to the four names, but it has, well, nothing to do with the other attributes. So here the solution and the four name is a transitive dependency, and what you need to do is create a separate table. As here, they have a solution ID and a solution which will just eliminate the solution from the first table. If the solution here is in the first table, it will have some dependency on the four names, which we don't want it if we want the third norm form applies. Also here is a BCNF example. Below we have a college enrollment table with column student ID, subject, and professor. In the table above, student ID subject forms the primary key, which means the subject column is a primary attribute. But there is one more dependency, the professor to subject. And while subject is a primary key, professor is a non-prime attribute that is not allowed by BCNF. What we can do is just separate these two tables as shown here. Well, that's all the 5 examples from non-normalized table to tables that satisfies the BCNF rules. Here is a QA session. Basically answer the question if you have. Thank you.